This video is about these. I bought 10 15 amp 400 watt Mosfet trigger switch drive module PWM regulator control panel. And what that really actually means in English is that you get this little thing. Get that out of the way. If we cut that open, we get this little board. And it says there HW-517 and then V 0.0.1. So I take that to mean version 1. And basically what you've got is an input and an output that are not connected, and then these two MOSFETs act as a switch to turn the input to the output, and then down here these 2 points act as plus and minus for a switch to switch these two MOSFETs. So when this closes, it switches these on, which allows current to pass from this side to this side, and it works. So this has become an electric switch, and there's a little LED there which is red, which comes on and says to you, I'm on, but hopefully you know it's on anyway. Right, let's wire it up. Right, positive out, positive in. There's straight through connection from one side of the board to the other side. So in to out, positive, always connected. So the switch is actually between V in minus and V out minus. So that's where the actual switch is. Right, now for out, I'm going to use this. That's a 12 volt 20 watt bulb, so that's 2 amps. So for out we will use that, and that's minus in there and plus in there. Right, for input I'm going to use this battery, BMS 3S, so 12 volts. There's our positive input, and I'm also going to put an extra wire in there because that's going to be our switch trigger. So I need to get that in there as well. And then on this side we've got our minus input, so that goes in there. Right, now on the bottom of this it tells you, it doesn't tell you on the top, but it says ground, and you might be able to see that the ground plane from here is connected all the way over to here. So in other words, everything is grounded, including that. So I don't actually need to connect to there because it's already connected to V minus. So this point and that point there are effectively connected already. Right, so if I touch this to what they call the signal line, it should turn those two MOSFETs on. The little red LED should come on, but the most important thing is this should come on. And it does. So there you are. We've got 12 volts going to a 12 volt bulb, obviously, and we're turning it on with a 12 volt bulb, but this turn on is using milliamps according to the specifications of this circuit, and all that is doing is switching the MOSFETs. So this is effectively an electronic switch. Off, on, off, on. Now let's try something that takes a bit more power. Right, the reason I bought these boards is because I want to be able to turn on and off something like a motor, and that motor might slowly wear away the contacts on a switch. because there's a jerk of current when you first switch it on. So let's try using this to switch the motor on. Now notice LED flashed on, but it's not on. Now every time I've tried this, this is what's happened. Watch. It's still running. So this is the fourth one of these. There's 1, 2, 3. That one's number 4. All do the same thing. As soon as you connect them to the motor, everything stops working. And if I test those Mosfets, they will be short-circuited, meaning that they've blown. And the only way, of course, to turn this off is to disconnect it. Now, I don't know what the actual current is, but this says it's rated for 15 amps, and I'm pretty sure this motor is not drawing 15 amps. So 2 amps for the bulb, it can't. Whatever this is, I'm not really sure, but I'm absolutely sure it's not 15 amps. I could try putting a meter on it and all this nonsense, but it's simply not up to scratch. So these Mosfets are no good. So the thing has been made with Mosfets that are no good. Now I have got, and there's 2 left in here, I've got some Mosfets left over from another project that I was playing with. Now apparently these are in-channel Mosfets. I'll give you the numbers on these and the number on those later, because I can't see at the moment even with my glasses on. But what I'll do now is I'm going to put those 2 Mosfets on there and then test again. Right, to make things a little bit easier getting these off, I'm just going to cut the legs. 1, 2, 1, 2, so that's the legs cut. And then all I need to do is unsolder this. This is a bit in the way. I'm hoping I'm not going to damage that too much, but we'll see. Right, first I'm going to add a little bit of leaded solder. Try and that help get the temperature of heating of the whole thing down so that it should melt a little bit lower temperature, hopefully. Right, there we go, it's off. And we need to do the same with the other one. A little bit of leaded solder in there, there it goes. Oh, no. And it's off. And then I'm just going to add a little bit more solder to that so that I know we've got some leaded solder in there. Nice. Stir that in a bit, stir that in a bit. And then I'm going to do the same where the legs went. Oh, so that should be off. Get that leg off. That's that leg off. Oh, come on. Get that leg off. And then the last one. Right, you'll have to take my word for it, but if I get that up the right way, that says Nikos, which seems to be Nikos, and then if I can get the light right, P2003 BDG. BDG. So that's what that says. Right, now these 2 Mosfets that I've got here, like I say, I already had from a previous project. These are NCE 3095K. So they are NCE 3095K. We just check. NCE 3095K. Now, I've no idea if these are compatible, but as I've got them, we'll stick them on and see what happens. Right, I'm using some tweezers to try and hold that in place, and the biggest problem, of course, is always the same, trying to get enough heat in here, and this stupid plastic plugs up here are getting in the way no end. Hope I don't melt them completely. Let's try bringing this in from the other side to see if that will help. I'm certainly melting the blue plastic, I can see that. Well, we'll have to wait for a second and see if that's gone on. I think it might have done. And then we just want the two legs on. That's that one. And that's that one. Now, just going to get this one on. The problem, like I say, is that it's very difficult to tell whether you've actually melted the solder, but I think I have. A little bit of solder, press it down. I think that's gone on. And the same on this one. Right, so let's try it. There's the old Mosfets that I took off. There's the two new ones that I've put on. The flickering is me not holding it very well, but did you see the red lights come on? I'll try and get my hand on top of it to hold it still. Now, I'm not sure if they're getting warm. I'm not sure you can hear me, but I'm not sure if they're getting warm, but I don't think they are. Now, I don't think these two Mosfets are any more special than these two. So I'm wondering if this circuit board was built with fake components and that these Mosfets here that were on here are simply not what they claim to be. I don't know how you would ever know, and I don't know if this is long lasting. I mean, I don't know if this is always going to work, but you can see that the LED has now come back to life, and so this board now works. So I've now got another, I think it's 6 of these, so I'm going to order a whole load of these Mosfets, and then I can simply just replace the Mosfets on the other boards. I won't even bother to run them and let them break. I'll just put new Mosfets on. Now, this is a pretty pointless video, I get that, but some people out there it might help, because if you've bought an HW517 board and had it instantly not work, or it's blown itself up or whatever straight away, you now know that by changing these two Mosfets, or these two dodgy Mosfets for two better ones, this board will work. Now, of course, equally it's possible that I was just unlucky with who I got these from, and that somebody else buying from China, these will work perfectly straight out of the bag, but for me, they don't work. Thanks for watching.